Let's take a look at some graphs and look at the derivatives of functions and pull off increasing, decreasing, and then concavity. This is the graph of f of x, so it is a function itself. It goes on forever in both directions. We can pull the first derivative off this. So we name this as the first derivative because we like to look at these charts. We know that at horizontal tangent lines, the derivative is 0. So we have horizontal tangent lines there and there, so our derivative is 0 there. And we also have all the tangent lines over in from negative infinity to 0, all have negative slopes. Here in the middle, they're all positive slopes. Over here on the left, they're negative slopes. And so now we can pull off increasing and decreasing. This function is decreasing here until it hits a horizontal tangent line. So we have negative. It's decreasing, negative infinity to 0. It's also decreasing here from 2 to infinity, and then increasing here in the middle. Now let's take a look. What if this was a graph of the derivative instead of the function? So now we have a graph of the derivative. And again, let's go ahead and create a sign chart, look, number line for this. And this is the graph of the derivative, and the derivative is 0 here. It is 0 here, and it is 0 here. The derivative values, here they're positive, here they're negative below the axis, here they're positive above the axis, here they're negative below the axis. Again, it's the function is the derivative, so the derivative is positive here, it is negative here in this interval, it is positive here and negative here. We can look at concavity as well, or let's go ahead and name what we have. Here it goes from positive to negative. This is a relative max. From negative to positive, this is a relative min. And from positive to negative, this is a relative max. We can pull off concavity. If it's a relative max, then what is happening here, it's coming around like this. And then it's going relative min, and then here, whoops, sorry, going against the grain there, we get this. And so what does this mean? We have a relative max here, which means the curve is doing this, relative min doing this, relative max doing this. Notice what happens up here with the derivative. Here we have a change. Here we have a change. Let's go ahead and mark those. This, where there is a critical value on the second derivative, is where the concavity changes. So for the first derivative, where you have a change in sign, you get a change in the derivative. It is from positive to negative. You get a relative max here. From negative to positive, you get a relative min. From positive to negative, you get a relative max again. And then the concavity changes here. So we are going from concave down to concave up here, switching. And then switching here again from concave up to concave down. So we can go ahead and answer our questions. From 1 to 2, is it increasing? And the answer is here from 1 to 2, is this function increasing? The answer is yes, it's increasing there, so that's true. From 1 to 2, is it concave down? From 1 to 2, is it concave down? Well, it is concave up here, so the answer is false for that one. It has a relative min at 0. Well, you know, it looks like that, but this guy's the derivative. That's not the function. So the derivative has a critical value there. The original function does not. The original critical values for the original function occur when the derivative changes, positive to negative, negative to positive, positive to negative. So we have to be careful. I do recommend anytime you see a graph of the derivative, make a sign chart. Then ignore the graph for a little bit. And what do you know just from that? And you're pulling these values from here, negative here, positive here, negative here. Then ignore all this. Come down here, name your relative extrema, take a look at concavity. Now go look how that looks back up in the graph again. One last one for us. This again, this guy is y equals the derivative of x. So this is the derivative of x again. So let's go ahead and make our first derivative number line. And we're getting here at 0. Sorry, it's back underneath in my toolbar. I can't write it. At negative 2, the first derivative is 0. A little to the right of negative 1, it's 0. And a little to the left of 2, it's 0. Again, we can pull the y values off of this graph that we're looking at, but this is the graph of the derivative. So the derivative is positive over here, negative here, positive here, negative here. Let's go ahead and write those in. So to the left of negative 2, they are positive. Between negative 2 and a little more than negative 1, they're negative. From that negative 1-ish all the way up to almost 2, they're positive values. And then to the right of that, they are negative again. So what's that give us from positive to negative? It's a relative max. From negative to positive, it's a relative min. From positive to negative, it's a relative max. Go ahead and draw your concavity as well. And the concavity is this. And then a relative min. And then a relative max. And so we have concave down, up, and then down again. And it makes sense right here that that's occurring because we get this and this. Right? That's where the first derivative is changing direction. And so the way that it is increasing and decreasing is changing. So let's go ahead and now answer these questions. And we're going to answer the questions based on the sign chart that we made, not this graph. We're going to come down here and look at this. So from 0 to 1, the graph of f is increasing. From 0 to 1, that's lying in here, increasing. Yes, the first derivatives are positive, so the function is increasing. From negative 1 to 0, the graph is increasing. Negative 1 to 0, that is still in here, so yes, that is true. From negative 2 to negative 1, the graph is concave up. From negative 2 to negative 1, the graph is concave up. Well, it's concave up for part of it, but not all of it, so that answer is false. And then from negative 1 to 0, the graph is concave up. The graph from negative 1 to 0, concave up. So remember we said something interesting is happening here? Where that's happening is right here. And so this is a little to the right of 0. So is it concave up everywhere? From negative 1 to 0? Yes, it is. The answer is true. So these were true, true, and false. So that's it. Hope you're having a great day.